Sine law part 2, the ambiguous case. Let's just first visualize the ambiguous case. So that means two triangles. Let's just actually take a step back here and look at our cast rule. C, A, S, T. If we have an angle all the way from 0 to 180, which is what all the angles in a triangle would be, we're going to get sine theta is positive here and sine theta is positive here. So that's why we get an ambiguous case, because we can have an angle here, we can have an angle that is greater than 90, that has both a quadrant 2 answer and a quadrant 1 answer. So that's like talking just trig here. That's why it happens. That's why the information given is not complete enough to ensure that we only have one answer. So it occurs when you're given a theta, or an angle that is acute, which is less than 90 degrees, and you're given a side, which I have called adjacent because it's right beside that, and you've been given an opposite of the angle. Now it occurs when opposite over adjacent is less than 1 and sine of theta, which is given, is going to be less than opposite over adjacent. So that's when it occurs, because then you can have two different triangles. So this is acute, and we're given this one, and you can see that this one is shorter than this one, so then the ratio is less than 1. And we have one line that can be drawn here, but we can also have another line, another side that can be drawn this way. Now these two are the exact same. We're not given what this base is, but we're given what this side is, and if these two are exactly the same, we can have the acute triangle, which means that this angle is acute as well. Or we get our obtuse angle, which is obtuse, which is greater than 90 degrees. Why? This one right here is our reference angle, and this is our quadrant 2 related angle. So I'm just going to go through a few questions here, and we're going to determine whether or not the ambiguous case is needed. So, 1. In triangle ABC, little a equals 20 units, C equals 16 units, and angle A is 30 degrees. How many triangles can be drawn? Well, here's the thing. We have a couple of information, right? We have this A, and we have the opposite side. And we know that A is acute. So if we have an opposite, okay, an angle and an opposite side, our spidey senses are kind of tingling a little bit, because we know that we have an acute A and we have the side that's beside it. So let's just draw this. So I have, my angle here is 30, and my opposite is 20. We're going to call this C, and I'm going to call this one right here 16. So let's do a little bit of analysis. Opposite over, not hypotenuse, opposite over adjacent is 20 over 16. Whew! Thank you, mathematical gods. 20 over 16 is going to be greater than 1. So, no ambiguous case. Because if we look back at our notes here, is theta acute? Yes, it was. So we have to follow this here. Is opposite over adjacent greater than 1? Yes. So then only one triangle is possible. So we can go back and just say simply one triangle possible. To solve, use sine law on one triangle. Just for kicks, I'm going to say heart smiley face. Thanks, mathematical gods. It's way less work if there's one triangle. Let's do example 2. In triangle ABC, A equals 7 units, C equals 16 units, and the measure of angle A is 30 degrees. How many triangles are possible? First things first, let's draw this sucker out. Again, my spidey senses are tingling because I have an acute angle and I have its side. So I need to do a little bit of further analysis here. I have my acute angle here of 30. My A is going to be 7. And my C is going to be 16. So in order to draw this to scale, maybe what I'll do is I'll do this, like that, and like this. Yeah, I like that. So this is going to be 7. And if this is my A, I'm going to call this one my C, so that is 16. So let's do some analysis. Opposite over adjacent is 7 over 16, whew, which is less than 1. So if I were to go back to my constructing triangles here, I say is theta acute? Yes. Is opposite over adjacent greater than 1? Oh, I should actually have it here. No. So is sine theta greater than opposite over adjacent? So let's see. I know that my sine of theta, which is 30, equals 1/2. And I know that 7 over 16 is less than 1/2. Why? Because 1/2 is 8 over 16. So I'm saying that sine 30 is greater than 7 over 16. So what does our constructing triangle say? If sine of theta is greater than the ratio of sides, then no triangle is possible. Woot woot! So we can say no triangle possible. If we just kind of mistakenly went in here using our sine law, so sine of 30 over sine of, sine of 30 over 7 equals, because here's our couple of information, equals sine of C over 16. Here's another couple of information. I would say that sine C equals 16 times sine of 30 all over 7. That means that sine of C equals 1.14 da, 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 which when you put into, when you find the angle of, if you say C equals sine inverse of 16 times sine 30 over 7, you get an error. Why? Because sine ratio is greater than 1. That is impossible. So you know that if your sine, if you find out what the sine of that angle is greater than 1, you know that there's an error. So no triangles are possible. Example number 3. In triangle ABC, A equals 10 units, B equals 16, and angle A is 30 degrees. How many triangles are possible? Fully solve for both. All right, so that's kind of our little bit of a hint. This is our ambiguous case. And again, our spidey senses should be up because we have an acute angle and the opposite side. So let's look at this. We have A, we have B, or let's say that this is A. And this is going to be our little a, and this is our angle B, and this is going to be our little b. So A is 30 degrees, little a is 10 units, not big B, but little b is 16. So triangle analysis. We have opposite over hypotenuse, which is 10 divided by 16, which is 0.625. Sine of 30, our given theta, is 1/2. So we're saying that sine of 30 degrees is less than opposite over hypotenuse. So let's look at our flowchart again for constructing triangles. Is theta acute? Yes. Is opposite over adjacent greater than 1? Yes? No. It's less than 1. It's 0.625. So no. Is sine theta greater than opposite over adjacent? No. It's less than. It's not equal to, it's less than. So that means that we have followed the flowcharts to yes. Is opposite over adjacent less than 1? No. Sorry, is opposite over adjacent greater than 1? No, it's not. It's less than 1. And we've gone down to this option here where 2 triangles are possible. So this right here is our ambiguous case. 2 triangles possible. So that means we're going to have to solve for this length here, which will change, this angle here, which will change, and this angle here, which will change. So we have 2 triangles here because these 2 guys are equal. So first things first, let's solve for the acute triangle. That means that this angle here is less than 90. It's the bigger triangle. That's what's a little confusing about it. It's the bigger triangle, but it has the angle that is less than 90. So I'm just going to draw this guy right here, just the way I see it. This is 30. This is 16. This is 10. And now what we need to use is our couples of information to solve for the other sides. So we need to solve for C, we need to solve for B, and we need to solve for little c. So I'm just going to put stars beside the things that we need to solve. So let's use our couple of information that we know. We know that 30 degrees matches up with 10, and we can use this just by one missing of couple information to figure out what this angle is, and then we can solve for both c and little c. So sine of 30 over 10 equals sine of b over 16. So if we isolate that sine b, that's equal to 16 times sine of 30 over 10. If we want to solve for angle b, that is sine inverse of 16 times, that's multiplication, sine of 30 over 10. So that means that angle b is 53 degrees. So now we've solved for b. Woohoo! C is simply 180 minus 53 minus 30, because now we know what b is. It's 53. There are only 3 angles, they all have to add up to 180. So that means that C is 97 degrees. Now, since we know the angle C, we can use this couple of information to find out what the length of C is. Now what you want to do again is go to the original one that we do know. So sine of 30. Actually, I'm going to flip it this time because I'm solving for a length. So I know that 10 over the sine of 30. It's just easier this way. You don't have to. You can keep consistent, but there are fewer mistakes this way. Equals little c over sine of 97. C equals 10 times sine of 97 all over sine of 30. C equals 19.9 units. Great! So now we have our acute triangle. And why is it acute? Because all of the angle that you first solve for is going to be less than 90. What about this other one? Okay, it looks kind of like this. This is our obtuse. Why? Because B is greater than 90 degrees. So I know that this guy right here is going to be 30 degrees. We know that this guy right here is 10 units. This is 16 units. Now, the way to find the obtuse B, we figure out, or we remember what B is. So theta reference is the original B, which is 53. And we go, well, what is this in quadrant 2? I say 180 degrees minus 53 degrees. The new B is going to be 127 degrees. So we now know what B is. Since we know what B is, we can find out, let's just write down what these letters are. Since we know what B is, we can find out what C is. So we know that 30 plus 127 plus whatever C is has to be 180. So we're going to say C equals 180 minus 127 minus 30. So that means the measure of angle C is going to be 23 degrees. Great. So now there's only one last thing that we need to do, and we need to solve for length C. So length C, the way we do that is we're going to use the couple of information here. This one and this one. So since I'm finding a length, I'm going to put the length on top. So 10 over sine 30 equals little c over sine sine of angle C, which is 23. So I'm going to say C equals 10 times sine of 23 all over sine of 30. And that means that C equals 7.8 units. Phew! Okay, so that's a big solution. So what is going to be really helpful is if we separate it into two triangles here, if we just write down A, angle B, angle C, and little a and little b, and little c, this will help us organize our work. So we know that in both cases, let me just write this out, angle A, angle B, and angle C, little a, little b, little c. So in both cases, we know that angle A is 30 degrees, and in both cases we know that little a is 10. And in both cases, we know that little b is 16. What we had to do is we had to solve for angle B. So I'm just gonna highlight the green stuff which we knew. I'm gonna put a star beside the things we had to solve for. So in angle B, we simply use sine law to find out that B is 53 degrees. We subtracted 180, or we subtracted 30 plus 53 from 180 to get C, which was 97 degrees. And we used our sine law to find out what our length of C is, which was 19.9 units. Now with our obtuse angle, we took our angle B, okay, our acute angle B, and we found what is it in quadrant 2. The related angle to 53 is going to be 127, and we simply subtracted 30 plus 127 from 180 to get 23 degrees. And we used sine law to figure out that C was 7.8 units.